Hey math kids, today we're going to look at conditional probability. We're in chapter 10, section H, and the conditional probability formula looks like this. And this is probably the most confusing part. It's the probability of A given B. So if we know that, given right there. So if B has already occurred, what's the probability that A will also occur? So we'll look at this in the context of a few examples, 2 to be exact, and see how that goes. So it says, we're on example 21. It says, in a town, 25% of residents own cats, 55 own dogs, and 30 do not own either. Okay, it says draw a Venn diagram to describe the situation. So we'll do that. So we have cats, we have dogs. Now, we know that 70% of all the pet owners, this would be 70% because this is none. So out here is going to be 0.3. And we don't know the intersection. We know that the entire circle of C would be 0.25. And so if we just want this piece, it's 0.25 minus x, then parentheses, then parentheses. And then this is similar thinking, 0.55 minus x. Okay, so that's our Venn diagram. And then it says find the probability that a randomly selected resident owns a cat given that they own a dog. So we want to know the probability that a resident owns a cat given that they own a dog. So that's reduced to that, which we could even write, since we've defined it C and D, we can do probability of C given D. Now, let's see. We need to figure out a few things, because this formula is going to require that it's C and D over probability of, what was our B? D. Okay. So that's what it is for our specific situation. So we need these pieces to plug in. And so what we can do is we can just look at this situation that I've circled here. Now we know this represents 70% because 30% have none. And so if we add these together, we're going to get 5, 6, 7, 80%. So that's too much. So we know that 10% of these have both. So we're going to say both equals 10%, which means that P of C and D also equals 10%. So in this formula right here, we have 10%, or 0.1. Move this over just a little bit. So 0.1 divided by probability of having a dog, which was 55%. And so if we do 0.1 divided by 0.55, I'm going to open up a calculator real quick. 0.1 divided by 0.55 gives us about 18%. We want to go to 3 decimals though, and 0.182 would be the probability of these occurring. Okay. Now there's another part to this question. It says, find the probability that a randomly selected resident does not own a dog, given that they own a cat. So we want probability that we get not a dog, given we know they own a cat. Okay, so it's going to be probability of not dog, or sorry, cat, yeah, not dog and cat, and then probability of cat. All right. So if we look at our Venn, let's just draw a different Venn diagram. It's a little too messy right here. Okay, so we found out that the both section is 10%, or 0.1. Okay, and so if we do 0.25 minus 0.1, we get 0.15. If we do it over here, we get 0.45. And we still have our 0.3 on the outside. All right. So if we have that, we want to know the intersection of not dog and cat. So this was our cat, this was our dog. So if we just want anything that's not, let's see, anything that's not dog is going to be all of this, including just this piece of the cat, okay? And then cat is going to be the entire circle. So we want the piece where they intersect. So where the blue and the yellow intersect is just right here with the 0.15. So we get 0.15, and then probability of cat, well, the total cat was 0.25. And so if we go back to our calculator, we say 0.15 divided by 0.25, we get 0.6. And so that's our probability for that situation. Okay, let's move on to example 22. A top shelf in a cupboard contains 3 cans of pumpkin soup, 2 cans of chicken soup, the bottom shelf, okay, so this is top shelf. Now we have bottom. Now the bottom shelf contains 4 cans of pumpkin, and 1 can chicken. Lukash is twice as likely to take a can from the bottom. So, twice as likely. And so it says, suppose that Lukash takes 1 can of soup without looking at the label. Find the probability that it is chicken. Okay, so we want to find probability of chicken. So obviously we'll call this P and this C. We want to find the probability of chicken. And so let's kind of map out the situation using a tree diagram. Okay, so if we're going to choose a shelf, there's a 1/3 chance we'll go to the top and a 2/3 chance that we'll go to the bottom. And then from there, if we go to pumpkin, we have a 3/5 chance, a 2/5 chance. And then on the bottom shelf, it's a 4/5 to 1/5 chance. Okay. And so if we're trying to find probability of chicken, we just have to follow the 2 paths that can get us there. So we could go this way, or we could go this way. Okay, so we have 1/3 times 2/5 for that one, and then we have 2/3 times 1/5. Okay, so if we multiply those out, 1 times 2 is 2 over 15. Multiply this one out, it's also 2 over 15. Okay, since there's two ways to do it, we need to add those together. So we end up with a 4 over 15 chance on that one. Now part B, suppose Lukash takes 1 can of soup without looking at the label. Find the probability that it was taken from the top shelf given that it was chicken. Okay, so now what we're trying to find probability of top shelf given chicken. So if we write our conditional probability, it's going to be probability of T union C, or sorry, T intersect C over probability of C. Now, since we already found the bottom right here, P of C is right there, we can just write that into our formula. And now, if we want to see probability of top given chicken, that's essentially just asking for this one, because that's top given chicken, because we know that this isn't going to occur, and so we just need to do 1/3 times 2/5 to find that. And then we need to simplify this. So on the top, it's 1 times 2 is 2 15ths over 4 15ths. Now, a cool thing about fractions, it's a shortcut. If the denominators are ever the same, you can cancel them. So we're left with 2/4, which is 1/2. Okay? If you need additional help, please come to Math Lab. Until then, calculator.